Hello. In this lesson, we will be looking at and calculating with the combined gas law. Previously, we have learned about both Boyle's law and Charles' law. Each of those laws illustrated a relationship between either pressure and volume or volume and temperature in an ideal gas. The combined gas law merely combines those two ideas together to formulate one equation. So instead of having pressure and volume separate from temperature, we keep it all together. So we have our P1 or V1 and T1, our initial pressure, temperature, and volume, and we know that will equal, according to the constant, to P2, V2, and T2. So this allows us to calculate a system that has gone through some sort of change. So either the pressure and volumes change or the temperatures change, but we are able to calculate the other quantities associated with that change because there is a constant within the system, and we will take advantage of that to calculate it. So, first example, we'll look at pressure calculation. So, a quantity of gas occupies a volume of 1 liter at 1 atm or atmospheric pressure and 80 degrees Celsius. So I have volume, pressure, and temperature. So I want to know what pressure is required to compress the gas to a volume of 500 milliliters at 40 degrees Celsius. So now the volume has been changed and the temperature has been changed, so I want to know what the pressure is. I also want to organize my data and also make sure all the units are consistent. So I have to make sure everything's the same across the board so that I get an accurate calculation. I'm going to write down what I know first. So V1 I know is 1 liter or 1 dm cubed. I know that my pressure initially is 1 atm. My initial temperature is 80 degrees Celsius, but I have to convert that to Kelvin, so that's 353 Kelvin. My change in volume is now 0.5 dm cubed. My new pressure, well, that's what I'm looking for, and the temperature is now 40 degrees Celsius, which is 313 Kelvin. So the first thing I'm going to do is I'm going to set up my combined gas equation. P1 V1 equal over T1 equals P2 V2 over T2. Next, I'm just going to rearrange it and isolate it for my unknown. In this case, it is P2. So P2 is over here. I'm just going to rearrange it. P2, well, that's going to be equal to P1 V1 T1, and the inverse here, T2 and V2. Next, I'm going to just insert all of my known quantities. So P1 is 1.0 atm. V1 is 1.0 dm cubed. T2 is 313 Kelvin. All this is divided by T1, which is 353 Kelvin, and my V2, which is 0.5 dm cubed. Plug that in my calculator, and that equals 1.8 atm, or 1.8 atmospheres. So, and this actually kind of makes sense. If I'm going to shrink my volume and also lower my pressure at the same time, I would have to, or lower my temperature at the same time, I'd have to increase the pressure in order to accommodate this. So this is a good question that illustrates like how changes on any of the variables will affect the other variables within the equation. All right, let's take a look at one more example. We have a quantity of gas that has a volume of 2.5 liters at 760 millimeters mercury and 20 degrees Celsius. If this gas is then compressed to a volume of 750 milliliters by a pressure of 2 atmospheres, what is the temperature in Kelvin? So right off the bat, I have all these different mixed units. So I'm going to first write down what I know. V1 is going to be 2.5 dm cubed. P1, 760 millimeters mercury. Well, that's just 1 atmosphere. I'm going to convert that to atmospheres because atmospheres I always find is easier to work with. So just 1 atmosphere is easy. And my T1 is 20 degrees Celsius, and that's equal to 293 Kelvin. My V2, well, it's 0.75 dm cubed. My P2 is 2 atmospheres, 2.0 atmospheres. And I'm trying to find the new temperature, so I don't know what that is. Just as before, I set up my combined gas equation. P1V1 equals, or over T1 equals P2V2 over T2. I'm going to isolate T2. So I have T2, and that's going to be equal to P2V2 P1 over P1 and V1. So once I have that all rearranged, just plug in my values. So I have 2.0 ATM as my new pressure, my new volume, 0.75 dm cubed. My initial temperature, 293 Kelvin. My initial pressure was 1 atmosphere, 1 ATM. And my initial volume was 2.5 dm cubed. Now, to make sure I have the right units and solve for the right thing, I have to cancel them out. I have ATM and ATM, dm cubed and dm cubed. And so I'm left with Kelvin, and that's okay because I'm trying to solve for T2. Send this out, and my temperature is going to be 176 Kelvin, but with all the zigzags, I'm going to keep it at 180 Kelvin with significant figures. So I've shown you a couple of calculations, pretty straightforward. Write down everything you know on the left-hand side with all the variables. Use the combined gas equation to solve for what you don't know, rearranging, of course, for that variable.